In this video, we will go over application problems with a linear function. Let's see, finding a coordinate given the slope and a point. So this is for Math 161, Pre-Calculus 1, and we're looking at a topic in our Alex homework this week for section 1.5 homework. So here's the first one. Suppose that the monthly cost of a phone plan in dollars is a linear function of the total calling time in minutes. That makes sense because if you think about, well, I don't know, because I have a fixed plan with Verizon. I get unlimited minutes and everything, but you can think of it as like the more minutes you use, the more money you have to pay. I think it's this case like it's a linear function of the calling time. The more minutes you talk on the phone, the higher the phone bill will be. And they're saying with the slope of 1.15. Okay, so I think this is what's happening. Listen, we're paying 15 cents per every minute. Okay, because the slope is 0.15. So every minute we talk on the phone, we're paying $0.15, in other words, 15 cents more. The monthly cost for 150 minutes of phone call is $40.49. But even if you don't use the phone at all, there is a fee, right? Like you have to pay your initial fee to keep your service. So I think what we are gonna have is this money that we are paying is the number of minutes we talked on the phone plus that, how should I say that? Like the service fee, let's say. But all right, hold on. But I think I was adding too much story to it, but I hope this is making sense so far. I'm gonna go ahead and circle what they are giving us first, okay? Just using the slope, okay? What I circled in gray is a slope. And what else did they give us? They also gave us that a point, we have a point where the input is 150 minutes. And if you talk on the phone for 150 minutes, we paid $40.49. So that is a point. So if I may write this as 150 as the input and $40.49 as an output, you can see that we'll use this for our x sub 1 and we'll use this for our y sub 1, right? And you know where I'm going with this. I'm going to say the slope is equal to 0.15. What are they asking? They are asking what is the monthly cost for 220 minutes of call. Now, I can see us doing this two different ways. We can find the equation, find the rule, and plug in 220, or we can just do the slope formula. I think I'm going to go ahead and find the equation. I'm going to find the equation, and then I'm going to plug in this 220 minutes. So here's the equation, okay? My favorite. I'm going to do point slope form because we've been doing this for a while. Y minus y1 equals m times x minus x1. And guess what? If you and I divide both, don't do this though. I mean, you can, I guess. If you divide both sides by x minus x1, we really solve for the slope, right? And do you notice that this is just a slope formula, y minus y1 over x minus x1. So it's the same thing, really. But let me plug in what I have here, okay? Let me plug in everything that I have here. I know that y1 is 40.49. So I'll say y minus 40.49 equals the slope of 0.15 times x minus 150. All right, I'm going to, all right, let's solve for y. Let's solve for y, okay? So if I distribute this 0.15, I'll get y minus 40.49 equals 0.15x minus, I need to multiply. Let me get my little calculator open. I'm multiplying 150 times 0.15, and that is 22.5. Lastly, I should add 40.49 to both sides, plus 40.49. So the equation is y equals the cost of the phone bill is 15 cents per minute plus, now I'm gonna have to figure out what this is. All right, give me 1 second. So negative of that plus 40.49. That comes out to be $17.99. So that's like a fee that we need to pay to keep our service, even if you don't use any minutes. So if you use 0 minutes of calling time, you still have to pay $17.99. So this is the rule, and what we're gonna do now is we're going to plug in, because there's a question, right? They asked, what is the monthly cost for 220 minutes of call? So if I'm using 220 minutes, how much should I pay? So I'm gonna go ahead and find, I'm gonna plug in x equals 220 into my good function, okay? I'll make this a little bit smaller. I'll plug in 220 into this function. We'll get y equals 0.15 times 220 minutes, and we have to pay $17.99 for keeping our service. So how much is that gonna be? I'll go ahead and multiply over here. I will do 0.15 times 220, and then I will add, so the usage only is going to be $33, but I have to add $17.99. So the phone bill will be $50.99. So that is how I would do this, $50.99. But you know, Alex may explain it slightly differently. So if you like that method better, you know, come back and let me know. I was seeing that there's 2 ways to do this. We can use just the slope, but I wanted the whole equation because I kind of wanted to know what is that initial fee that we have to pay no matter how many minutes we're using. So the answer is $50.99. And because I did it this way for this problem, I'll do the same method for the other ones too, okay? So I'll keep on practicing writing the point slope form, distributing and solving for it, so that you see similar thing over and over. All right. Kwatam is driving to North Carolina. Suppose the remaining distance to drive is a linear function of his driving time. Now listen, think about this. The more you drive, the less distance to remains, right? Like if you drive 1 hour, then you have far to go. But if you drive 5 hours, maybe you're almost there. So that's why the slope is negative 0.8. Okay, the more you drive, the less distance that remains. So Gautam has 40 miles remaining after 40 minutes of driving. So what is the input here? Okay, so I have to be very careful with what is the input variable and the output variable. So the independent variable here is the minutes. Okay, the more you drive, the less miles you have to cover, to drive. So miles, the distance remaining depends on the minutes. So if we tell them, hey, how many minutes Gautam has been driving, we can tell, oh, he has so and so many miles to drive. So when I write, the reason I wrote this is because I think they give this to us in opposite order. So take a look. Gautam has 40 miles remaining. I'll just circle the 40 miles part. 40 miles remaining. After 45 minutes of driving. So the order they gave us the 40 first, and they gave us 45 minutes after that. But if you're not being careful, we can switch the X and Y. So look, the minutes, how many minutes has he been driving? he's been driving for 45 minutes. So 45 is actually the x value, the input value. And the output is that he has 40 miles remaining. So my x sub 1 is 45 and my y sub 1 is 40. I can see someone accidentally switching these two because if you're not being careful, the way the sentence is written, they gave us the output value first, okay? But because miles depend on the number of minutes, minute should be the input variable here, okay? Now, I think I forgot to highlight that one important number. They did say that the slope is negative 0.8. So I'm going to make a note that m equals negative 0.8. And I'm ready to do my point slope form because I have a point and a slope. Okay? Point slope form is y minus y1 equals m times x minus x1. And like I showed you like on the previous example, if you just divide both sides by this factor, that turns into a slope formula, right? Okay, but let me plug in everything I have. I have to do y minus y1, so y minus 40 equals negative 0.8 times x minus 45. I'm going to go ahead and solve for the equation, but after that I'll go ahead and plug in. Distribute this negative 0.8, we'll get y minus 40 equals negative 0.8x plus, because negative times negative is positive, but let me multiply. If I multiply 0.8 times 45, that gives me 36. So this is 36 right here. Lastly, I just need to add 40 to both sides. So the equation will be y equals negative 0.8x plus 76. Which means, now this is interesting. If he drives 0 minutes, what will happen if you plug in 0 here? If he drives 0 minutes, he's gonna have 76 miles to drive. So how far away is Guatam from North Carolina border? He's 76 miles away when he first started driving. What was the number they want us to plug in? Let me read the very last sentence. It said, how many miles will be remaining after 58 minutes of driving? I'm going to go ahead and plug in that 58. So let's say, I'm going to say plug in x equals 58. So the remaining distance will be negative 0.8 times 58 plus 76. All right, I'll go ahead and use the calculator to evaluate that. I mean, 58 is like close to an hour, right? So by doing this, I think we can even figure out his speed and everything, but I don't think we have to do all that. So if I multiply those two, I got negative 46.4, and I need to add 76 to that. So I'll do this minus 76, and the answer will just be a positive version of that. Because you see, positive number was bigger. So let me write down the answer, 29.6. So he will have 29.6 miles left to go. Sorry. Miles left to go if he drove for 58 minutes already. An interesting question will be something like, how many minutes will it take him to get there, right? So nobody asked me, but I wonder, I do want to find the answer, so I'll go ahead and add a page. So when will Gautam get to NC? At what time? Well, he is in North Carolina if the distance is 0, right? The remaining distance is 0. He doesn't have to drive anymore. He's there. So what I can do to figure that out is I can set y equal to be 0 and solve for the x value. So I'm saying Guatam is in North Carolina if the remaining distance to drive is 0. So I'm just going to go ahead and solve for it. I want to know how long his trip will be. So if I subtract 76 from both sides, and then divide both sides by negative 0.8. Okay, let's see. 76 divided by 0.8. Oh, okay. It's going to take him 95 minutes to get to North Carolina. This is going to be a 95-minute trip. So 1 hour and 35 minutes of Guatam driving to North Carolina. Interesting problem, but we really need to understand what X is and Y is in terms of this problem. X was the number of minutes he was driving, and the Y value, the output value, is the number of miles remaining, okay? So that was a fun example, but I think I only have one more left, so I'll go ahead and do that with you. Ooh, let me go ahead and draw circles around this. But you see the pattern, right? They give us point and a slope. So I find the equation and I just plug in the last part. They have a question like on the very last sentence. So I wonder if the last one looks like this. All right. The height in centimeters of a candle is a linear function of the amount of time in hours. Okay, so let's think about this. The longer you burn a candle, shouldn't it be shorter, right? The longer you burn it, it's gonna just burn down and the candle length will be shorter. So we're expecting to see a negative slope. Let's see what the slope is they're giving us. The slope of negative 0.45, negative 0.45. So what's happening? Let's see. So every hour in 1 hour is getting shorter 0.45 of a centimeter. Suppose that the height of the candle after 14 hours is 24 meters. Centimeters, not meters, oh goodness. So let me go ahead and organize my input and output first. So what is the input? The input is the time, right? Okay. Why? Because depending on how long you have been burning this candle, we're going to find the height of this candle. The height of the candle depends on how many hours we have been burning this. So the input is hours, the output is the height. Okay? All right, hold on, I don't like the way it's written. Okay. So when they gave me an order pair, well, it's not an order pair, like input and an output, they mentioned that after 14 hours, it is 24 centimeters. So I can say the x coordinate is 14, the y coordinate is 24. So this is my x of 1, this is my y's of 1, and they also mentioned that the slope is negative 0.45. You know I'm about to do the point slope form. So here's the point slope form to find the equation of what's happening to this candle, okay? Y minus y1 equals m times x minus x1. It's going to be y minus 24 equals negative 0.45 times x minus 14. Okay? At this, I know I'm going over writing the equation kind of quicker because we spent more time during class on previous examples doing this point slope form. So by the time you're watching this video, you're probably familiar with writing the equation in point slope form given in a point and a slope. So let me distribute now. Y minus 24 equals negative 0.45x. And I'm doing negative times negative for the second multiplication. So I know the sign will be positive. But what is that going to be? Let me go ahead and type it in. 14 times 0.45. That came out to be 6.3. 6.3. Last thing that we are doing is adding 24. Adding 24 to both sides. So that's going to be 30.3. Okay, so here's the equation. Y equals negative 0.45x plus 30.3. This is important. What does 30.3 means in this situation? Imagine if you don't burn this candle at all, like at hour 0. You see, if I plug in 0 in here, this term will cancel out and say that the y is equal to 30.3. So 30.3 is not only the y-intercept, but in the context of this problem, this is the length of the candle if we don't burn it. So this is the length of the candle before we light it up. This is the original length of this candle, okay? Now, what did they want in this problem? I should go and read that last part. They said, what will be the height of a candle after 15 hours? Okay. Oh, whoopsie, sorry. Let me go up. It says, what will be the height of the candle after 15 hours? 15 is the input variable. So let me go ahead and plug in 15 in here. It's going to be y equals, oh, I said plug in. X equals 15. Negative 0.45 times 15 plus 30.3. Okay, so that's going to be 15 times 0.45, and the negative of that is, so the first part comes out to be negative 6.75, and if I add 30.3 to it, so what they are saying is in 15 hours, the candle will get shorter by 6.75 centimeters. So I'll add 30.3. So this candle will only be 23.55 centimeters long after 15 hours of burning. So how useful these equations are, because you can plug in any input value to figure out the height of the candle, okay? Another interesting example, the question that I could ask is, how many minutes do you have to wait until this candle is completely gone, like 0 centimeters tall? Well, you can set y equals 0 and solve for x that way. But now I'm thinking about it, a candle will never be 0 centimeters tall, right? Because I don't think it can burn down completely. So I don't think I will do that part. But that's enough for you to get started on your homework for this week, on this word problem section, because I believe they are similar. But if you see different type of word problem that are not as similar to these 3 that I went over with you in this video, please reach out to me. If you can email me those problems, maybe a screenshot of it, I can record another short video going over that particular problem. All right, have a great rest of the week.